Welcome to CyberFlow, your one-stop shop for cybersecurity education. This is a 100% free course for the CCNA. Our channel provides courses and tutorials to help you develop the skills and knowledge needed to learn networking, cybersecurity, and ethical hacking. But we're not just about education. We're also committed to making a positive impact. Our goal is to reach 100,000 subscribers and raise $100,000 for St. Jude Children's Research Hospital. By subscribing to our channel, you'll be supporting this important cause and helping to make a difference in the lives of children and families facing serious illnesses. You'll find the links and description. Also, we've created Anki flashcards to help you remember everything you're studying. You'll find them in the description below. Join the CyberFlow community today and help us achieve our goal. Hit that subscribe button and let's get started. Welcome back, class. Before we dive into today's topic, let's do a quick recap of what we discussed in our last video about Ethernet frames. Remember, the Ethernet header is composed of 3 fields: destination, source, and type. However, the preamble and start frame delimiter, SFD, are not considered part of the Ethernet header, even though they are sent with every Ethernet frame. So, if we exclude the preamble and SFD, the size of the Ethernet header plus the trailer is 18 bytes. Now let's talk about the minimum size of an Ethernet frame. The minimum size is 64 bytes, including the encapsulated payload or packet. If we subtract the 18 bytes of the header from the minimum frame size, we get 46 bytes. Therefore, the minimum payload size is 46 bytes. What happens if we send a payload packet that is less than 46 bytes? Well, in that case, padding bytes are added to the frame. These padding bytes are all zeros. For example, if you send a 34-byte packet, 12 bytes of padding will be added to reach the minimum frame size. To summarize, the preamble and SFD may or may not be included as part of the Ethernet header, depending on how you define it. However, they are included with every Ethernet frame. The minimum size of an Ethernet frame is 64 bytes, not including the preamble and SFD. This means that the minimum payload size is 46 bytes, and if the payload is smaller than that, padding bytes will be added. Now that we have refreshed our memory about Ethernet frames, let's move on to the main topics for today's video. Here is the same small network topology we saw in the previous video. Before we proceed, there are a couple of changes in this network. Firstly, I have upgraded the interfaces from Fast Ethernet to Gigabit Ethernet, hence the G0/0, G0/1, and G0/2 labels on each switch. Secondly, take a look at the MAC addresses. In the previous video, I used simple MAC addresses like A8AA, AA00, 0001 for PC1, and .0002 for PC2. But this time, let's use more realistic MAC addresses. Notice that the OUI, Organizationally Unique Identifier, which is the first half of the MAC address representing the device maker, is the same for all PCs, 0C2FB0. This suggests that all the PCs were manufactured by the same company. The second half of each device's MAC address is unique and represents the device itself. To keep things simple, I'll refer to the MAC addresses using only the last 4 digits. For example, PC1's MAC address will be 9D00, and PC2's MAC address will be 6200. Now, let's add another element to this network topology: IP addresses. Although we won't delve into the details of IP addresses in this video, we'll need them to explain something else later. The number 192, 168.1, 024ths represents the entire network shown here. The IP address 192.168.1.1 represents PC1, 192.168.1.2 represents PC2, 192.168.1.3 represents PC3, and 192.168.1.4 represents PC4. In the last video, we discussed how devices on an Ethernet network communicate using MAC addresses. However, when it comes to IP communication, devices need to know each other's IP addresses. This is where the Address Resolution Protocol, ARP, comes into play. ARP is a protocol used to dynamically map an IP address to a MAC address. When a device wants to communicate with another device on the same network, it needs to know the MAC address of the destination device. To do this, the device sends an ARP request broadcast message asking, "Who has this IP address?" The broadcast message is received by all devices on the network. The device that has the requested IP address responds to the ARP request with an ARP reply message, providing its MAC address. This way, The device that initiated the ARP request can update its ARP table with the MAC address of the destination device. Let's see an example of how ARP works in our network topology. Suppose PC1 wants to communicate with PC3. PC1 knows the IP address of PC3, which is 192.168.1.3, but it doesn't know the MAC address. So, PC1 sends an ARP request broadcast message asking, who has the IP address 192.168.1.3? This ARP request is received by all devices in the network, including PC3. PC3, recognizing its own IP address in the ARP request, responds with an ARP reply message saying, I have the IP address 192.168.1.3, and my MAC address is 0C2FB06A 3900. PC1 receives this ARP reply and updates its ARP table, associating the IP address 192.168.1.3 with the MAC address 0C2FB06A 3900. Now PC1 has the MAC address of PC3 and can encapsulate its IP packet within an Ethernet frame. The Ethernet frame will have PC1's MAC address as the source MAC address and PC3's MAC address as the destination MAC address. It's important to note that ARP is a dynamic process, and the ARP tables in devices can change over time. Entries in the ARP table have a limited lifetime and are refreshed periodically through ARP requests. This ensures that devices have up-to-date MAC address mappings for IP communication. That's a brief overview of ARP and how it helps devices on an Ethernet network communicate using IP addresses. In our next video, we'll delve deeper into the encapsulation process and examine how IP packets are encapsulated within Ethernet frames. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.